Hello my dear students, this is Akash HD. Welcome to the ASG physics classes. Hopes you all are doing really great. So students, in this video we are going to solve the question from the chapter Center of Mass belongs to the main chapter Rotational Motion. Okay, let's go through the question. The question is the center of mass of a thin rectangular plate with the sides of length A and B as shown in figure on next page, whose mass per unit area varies as this is given here, sigma equal to sigma naught x by AB, okay, where sigma naught is a constant would be how much here, okay. So when you will observe that this sigma is what? Mass per unit area, even this is called area mass density, okay. And you can see that this sigma, that means mass per unit area, is the function of x. That means what is happening? When we are going away from the origin, then what is happening? The mass is increasing, or we can tell mass is changing. Is it? Let's see here, please. Here you can see this diagram is there. This is the side A, this is side B. So when we are going along x direction, that time what is happening? Mass is changing because mass per unit area is a function of x, as I told you. But what about the y direction? In that situation, what is happening? The mass is not changing. How I am telling you? Let's see here. Let's take for example, here I am going to take one example, but before that, let's see what I am going to tell you. See, as mass per unit area is constant along a y direction, that is uniform mass density along y direction, hence what is the YCM here? Na? Because XCM, YCM both we have to calculate because this is the two-dimensional body. Let's take for example, here I have taken here one plate is there, na? As a sheet is there. So here what I am taking here, just here please, here I have taken, let's take this mass 1 gram, this mass 2 gram, this mass 3 gram, and next mass let's take 4 gram, and let's take this mass 5 gram. So here you can see very well, when we are going along which direction? X direction. What is happening? The mass is keep on increasing. That means we can tell along X direction which kind of density is there? Non-uniform density is there. But what about the Y direction? If I talk about here, let's take Y direction here. So here you can see very well, here if I draw here one line, now let's take for example, here I have drawn here one symmetrical line. This symmetrical line I have drawn here, okay. So in this symmetrical line, this is the symmetrical line. So here you can see in this symmetrical line, let's take for example passing through the middle. So this side, let's take this box, 0.5, 0.5, total 1. This is 1 gram, 1 gram, total 2 gram. 1.5 gram, 1.5 gram. 2 gram, 2 gram, total 4 gram. 2.5 gram, 2.5 gram. That means what is happening with respect to this symmetrical line? If you see total mass above and total mass down, it will be what? Same. Even see here, let's take 5 plus 4, 9, 9 plus 3, 12, 12 plus 2, 14 plus 1, how much here? 15. So what will happen that here, above this symmetrical line, the total mass will be how much here? For example, 7.5 gram, okay. And what about the downward mass? This will be also total how much here? 7.5 gram, is it? Now you can see very well, in this situation, what is happening that here, even here also, what is happening? This sigma is as a function of x here. That means non-uniform mass density along x direction. But we can consider the symmetrical concept will be applicable along y direction, as I have told you very well as example. So here you can see in the same way, here we can see here now, this sigma as a function of x, and we can tell along y direction it is not changing. So what will happen that here, as along y direction uniform mass density, and you can see very well along y direction what is the length is there? B length is there. That means from the symmetry the center of mass will be how much here? Half of B. That means somewhere in a middle, I will draw here one line. That means center of mass will lie on this line. Let's take for example on this line, somewhere it will lie, okay, somewhere it will lie. Center of mass will lie somewhere on this line, okay. That means what is the YCM coordinates? It will be half of B. That means how much? B by 2, okay. That means here YCM value is what here? B by 2, okay. So which option can be wrong? Option A is not possible because here the y coordinate 2b by 3. Here also this is not possible. B is there na, because 2b by 2. So maybe possibility option B and option C. Is it? So now we have to calculate XCM. Is it? Why we have to calculate XCM? Because the mass per unit area is changing along x direction. Is it? So now let's see here. So to calculate the XCM, what we have to do here? Let's see. We are seeing here. See, as mass per unit area is variable along x direction, that is non-uniform mass density along x direction. Hence, let us consider a strip of infinitesimal, that means very small, with dx at a distance x from origin. Okay, so here what I will take here, I will take here one strip. Okay, so if I will take here one strip, now let's take here I have taken here one strip. This will be very, very thin, but okay, to keep the things you can see very well, we have taken here like this strip. Okay, and for this strip, let's take here, this is the strip is there, now like this strip. What is the thickness of this strip? This strip is having thickness dx. Okay, so see this one here. This strip is having thickness dx. And how much distance? This is at a distance of x. Okay, so from here, I will draw here like this. Okay, how much distance is there from the origin? X distance is there. Okay, so here we are going to use here the continuous mass distribution way to calculate the center of mass. So here if I write, you know very well, as what is sigma is given, you can see very well. The sigma is given here, sigma naught x by AB. Is it? And what is sigma? This sigma is called here mass per unit area. Is it? So let's take this strip is having very small mass. Very small mass. How much I have taken here? Let's take the mass is dm here. Okay, so the sigma means mass per unit area. That means I can write here mass is dm by area. Let's take very small area dm. We know the total sheet is having area AB, length into breadth, but we are talking about this strip. So dm by dA here. Is it? So here we can write here dm by dA. Now you can write here, this is the dm, and what is the area of this strip. Okay, so see the thickness how much here, you can see this dx, and this length how much here, you can see this length is b, that means this length is also b. Is it? So this one we can tell, let's take breadth is b, length is dx, so I can write here what is coming here, see b into dx. What is area is coming? Sigma equal to this one here, it will come dm by b into dx. Is it? So now if I will write here further, so you can see very well, this and this I am going to equate here. Kindly see here this one and this one, if I will equate, so what will happen that here, this b and this b will cancel out. Okay, that means we can write here, see this dm will come here now. So this dm will come here, see sigma naught into x by a, and dx will come this side here. Okay, so this is the value of dm, that means the mass of this strip, sigma naught x by a into dx. Okay, this one you can make here equation 1. We have got the dm, the mass of the strip. Okay, now after that you can see the next one, see the center of mass of the plate along x direction can be calculated as, because YCM we got b by 2 by symmetry. So here we can write here along x direction, it is given here, XCM is equal to integration of, general formula is there, integration of x dm by integration of dm to deal with non-uniform mass density. Okay, now after that here we can write here, see, so if here I will write here, this is the integration x, what is the value of dm we have got, see sigma naught x by a into dx. Okay, so this value I am going to put now here, so this is x, and then we will write here sigma naught x by a into dx. Is it? And again this dm value, see please, sigma naught into x by a into dx. Is it? Now after that we are going to just take out the constant, sigma naught anyhow constant, so sigma naught by a will go outside, and this will become here what, x square into dx. Is it? Similarly in the denominator also, sigma naught a will come outside, sigma naught by a, so it will become here what, x into dx. Is it? Now what will happen that this sigma naught by a, this sigma naught by a cancelled. Okay, so hence we can write here this XCM value, XCM we are calculating, this will become here what, here integration of x square dx. Is it? So we are writing as the integration of x square dx by integration of x dx. Is it? And now we have to see the value of x is changing from where to where. Actually, we have to cover the full length from where to where. That means this is the strip is here, but if we are going along x direction and we are covering the complete plate, that means we can tell here one strip, here one strip, here one strip. Now so many strips are there, and all these strips we have to add, because integration means summation. That means first strip you can see here. At this point, first strip is there. That means here x equal to 0. Okay, so x equal to 0, then value of x will keep on increase. And when we will reach here, that means we'll reach to the last strip, and here it will come what? X equal to a. That means we have to integrate from x equal to 0 to x equal to a. Okay, so same writing here. See, x equal to 0 to a. Here also we can see here x equal to 0 to a. Is it? Now after that, we'll write here integration of x square dx. We know very well x cube by 3. Is it? X cube by 3, and here 0 to a. Is it? How we can write here? Because I think so you know this formula, x to the power n dx is equal to x to the power n plus 1 by n plus 1. Here we have to do plus c also if in case indefinite integration, but here definite integration, so no need of plus c integration constant. Similarly, x dx will be what here? This will become here x square by 2, 0 to a. Is it? Now next one what we are going to do, anyhow see this is the separate, so here we can write here 1 by 3 will come outside, then upper limit minus lower limit. So this will become here what? A cube minus 0 cube, that means 0 only. Is it? Here what will become here? 1 by 2, this will become here a square minus 0 square. Is it? So if we will solve here in this situation, what this will come? All these things are done. So see, here we are just going to fill here. See. So here what this will become here? Kindly simplify this. This will become here a cube by 3. Is it? Into this will become reverse, that means 2 by a square. Okay, so after that when we are going to just simplify this, what will come here? Hence this axiom will come 2a by 3. Is it? Axiom will come how much here? 2a by 3. Kindly see very well. Axiom is coming how much here? 2a by 3. Okay, so we know axiom is coming 2a by 3, YCM is coming b by 2. That means which option is correct here? The correct option is here option B is the answer. Is it? Can you see? Very well. So students, I hope so. This question of JEE 2025 is very clear to you, in which we have seen uniform mass density along y direction and non-uniform mass density along x direction. Okay? Keep studying, keep growing.